So the ninth question is, write 7 consecutive composite numbers less than 100 so that there is no prime number between them, right? So what the question is saying, we need to find out 7 consecutive composite numbers, right? We need to find out 7 composite numbers which are consecutive, right? So that, and first thing is they must be less than 100, okay? So that there is no prime number between them, okay? So before coming to this thing, I have written all the prime numbers from 1 to 100 using the sieve of Eratosthenes method, which we discussed in the video number 8.3.6, which will help us to solve these this question and some other questions as well. Okay, so if you haven't watched that video till now, go to the video number 8.3.6 and check how to find all the prime numbers from 1 to 100 in a very simple way. Okay, so from that I have written down all the prime numbers from 1 to 100. Okay, so let's now start to solve this question. Okay, so we need to find 7 consecutive composite numbers. Okay, so let's come here. So first prime numbers are 2 and 3. How many composite numbers are between them? Between 2 and 3 there are no other numbers, right? So there are 0 composite numbers between them. Okay, 0. From 3 and 5 we have only 4, which means only one composite number. Okay, from 5 and 7 we have 1. From 7 and 11, 8, 9 and 10, 3 numbers. Okay, from 11 and 13 only 2, no, only 1. Only 12 is the number, right? From 13 and 17 we have 14, 15 and 16, only 3 composite numbers. Okay, so from 17 and 19 only 1, which is 18. From 19 to 23 we have 20, 21 and 22, only 3 composite numbers. So till now we are not getting any perfect sequence of 7 composite numbers, right? So let's try to find out others as well. From 23 to 29 we have 24, 25, 26, 27, 28 and 29. Okay, so it will be 5 only, right? From 29 to 31 we have only 1. From 31 to 37 32, 33, 34, 35 and 36. 32, 33, 34, 35 and 36. Okay. From 37 to 41, 38, 39 and 40. Only 3. So till now the maximum number of consecutive composite numbers we got is 5. Here and here, right? From 41 to 43 we have only 1. 43 to 47, 3. From 47 to 53, 5. Okay, then from 53 to 59 again 5. Okay, from 59 to 61 we have only one composite number between them, and here 61 to 67 we have 62, 63, 64, 65 and 66, again 5. So we are not getting the required number. From 67 to 71, what is the number here? 68, 69 and 70, which means 3. From 71 to 73 we have only one number. From 73 to 79, 74, 75, 76, 77, 78 and 79. Oh. So we have 6 numbers, but still we don't have 7 numbers, right? So let's continue. From 79 to 83 we have 80, 81, 82, only 3 numbers. Okay, from 83 to 89 let's try to find out. 84, 85, 86, 87, 88, only 5. And now come on to the last, 89 to 97, 90, 91, 92, 93, 94, 95 and 96. Yes, we have 7 composite numbers between 89 and 97. So what we need to write is, we have to write those numbers. So the numbers will be, after 89 what we have? 90, 90, 91, 92, 93, 94, 95 and 96. So these are 1, 2, 3, 4, 5, 6 and 7. So these are the 7 composite numbers, so that all the numbers are less than 100, right? And there is no prime number between them. Now the next question is, express each of the following numbers as a sum of 3 odd numbers, odd primes. So we have these numbers 21, 31, 53 and 61, right? We need to express these numbers as sum of 3 odd primes. We need prime numbers which are odd, and those we need to take 3 odd prime numbers, so that sum of all those numbers come out to be this and this. Okay. So before continuing to this, let me erase this thing. Okay. So first let's go with 21. So first of all, let me take 3. Okay. We have the first odd prime number is 3, right? Let's take 5 then. 3 plus 5. What it comes out to be? 5 plus 3, 8. Okay. So 21 minus 8 will be 13, right? 13 plus 5, 18. 18 plus 3, 21. 21. Now check 3, 5 and 13. All these are prime numbers or not? 3, 5 and 13. We have 3, we have 5, let's say we have 13. Yes. So we are done with this example. Okay. So the second is 31. Now again let me try with 3. First let me take 3. Okay. If I take 5 again, okay, we have 5 plus 3, 8. Okay. Now what I need is 31 minus 8 will be, it will be 23, right? Let's try to sum up these. 23 plus 5, 28. 28 and 3, 31. Okay. Now let's check 3, 5 and 23 are odd primes or not. 3 is prime, odd prime. 5 is odd prime, right? And 23. Do you have 23? Yes. We have 23 as well. So all these are odd numbers and all these are prime numbers, right? So we are done with this also. Okay, now we have 53. So as the number is big, so let's not try with 3. Let's try with 5 or 7. Let's say we take 7. Okay. 7 plus we need to now, after 7, let's take 11 or 13. Let's try with 13. Okay. Okay, we have 7 and 13. 30 plus 7 is what? 20. Okay. So now what we are left with is, what we are left with? 13 plus 7 is 20. Okay. So 53 minus 20, it will be what? 33. Okay. So is 33 a prime number? No. So we can't use this. Okay. So let's try some other combination. Let's try with 3 only then. First number we take as 3. Okay. Now with 3, let's try 7. If we take 7, then we get this 10, and then we need 43. Do we have 43? Yes. So 3 plus 7 plus 43. Okay. So add this. 43 plus 7 is what? 50. 50 plus 3 is 53. So that sum is good. 53. Now let's check. All these are odd numbers. 3 is odd number, 7 is odd number, and 43 is odd number. Okay. So now check if 3 is prime number. Yes, 3 is a prime number. Is 7 a prime number? Yes, 7 is a prime number. Is 43 a prime number? We have, yes, 43 is also a prime number. So this is also done. These three parts we are done. Now let's try with 61. Okay. So for 61, so this number is big. So let's again try with, let's say 7. Okay. So there is no specific rule of trying all these numbers. We can try any combination. It's not necessary that the combination that I am making is the only combination. There can be other combinations as well. Okay. So first I am trying with 7. Let's say I am taking 13. No, not 13 this time. Let's say I take 11. So 11 plus 7 is what? 18. Okay. 11 plus 7 is 18. So 61 minus 18. What it will be? 43. Right? If I write 43 here, so let's check the total now. 43 plus 11 plus 7. Okay. So 3 plus 1 4. 4 plus 7 11. 1 borrow. Sorry, not borrow, carry. 4 plus 1 5 and 1 6. 61. So the sum is 61. So we are good till now. Now we have three numbers. Let's check all these are odd or not. 7 is odd number, right? 11 is also odd number. 43 is what? Odd number. Okay. So now check all these numbers whether they are prime or not. 7 is a prime number. 7 is a prime number. 11 is a prime number. Yes. And 43 is a prime number. Yes. Okay. So now this way we have found all the numbers. So question number 11 is, write 5 pairs of prime numbers less than 20 whose sum is divisible by 5. So what we need to do is we need to find out 5 pairs of what? Of prime numbers. So we will find 5 different pairs of prime numbers which are less than 20. Okay, so less than 20. So from this list we will only consider the prime numbers till 19, right? Because all other numbers are all more than 20. Okay, whose sum is divisible by 5. So sum of that the numbers which are in pair, the sum must be divisible by 5. So let's try to find out all these pairs. Okay, so first of all let's take the first number, prime number, which is 2. Okay, first number is 2. Okay, so if you pair 2 with any other number, okay, let's try this with 3. Okay, 2 plus 3. Okay, so we took first two prime numbers. Okay, so 2 plus 3 is what? 5, right? And 5 is what? 5 is divisible by 5. Obviously, right? Divisible by 5. Okay, right? So we are done with one pair. So let's try second. Let's take what? Let's take 7 plus 13. Okay, let's take 7 and 13. 7 plus 13. What will it come out to be? 13 plus 7 is what? 20. And we already know 5 fours are 20, right? So 20 is divisible by 5. Okay, it is divisible by 5. Okay, so let's try another pair. Let's try 3 and let's try 17. Right? 17 plus 3 is what? Again 20. And it is divisible by 5. Right? Okay, so we have 1, 2 and 3 pairs. Now find out other pairs. What can be the other combination? Can we try 2 plus 13? Can we try? 13 plus 2 is what? 15, right? And we know 5 3s are 15. Okay, which means 15 is divisible by 5. Okay, so we have 4 pairs with us, divisible by 5. Okay, now let's try 11. We have plus 11 plus 9 is 20, right? But 9 is not a prime number. So 11 plus 4 is 15, but 4 is also not a prime number. Okay, so let's try 11 with what? Let's try with 19. 11 plus 19. Let's sum this up. 19 plus 11 is what? 30, right? Now you may ask, we need numbers less than 20, but it's 30. But read carefully. We need pairs of prime numbers which are less than 20. Our prime numbers, the pair 11 and 19, both these numbers are less than 20. They are not saying that the sum must be less than 20. Sum can be any number, right? So that's why this is also a valid combination. This is also divisible by 5, right? So we got our 5 pairs. So these will be 2 plus 3, 7 plus 13, 3 plus 17, 2 plus 13 and 11 plus 19. Okay. Now let's come on to the last question of this exercise 3.2 of NCERT. So these are the fill in the blanks. Now first part is a number which has only two factors. Sorry. A number which has only two factors. A number which has only two factors is called. A number which is having only two factors is called what? Is a prime number, right? We are already doing this prime number. Okay. A number which has more than two factors is called what? Is what? Composite number, right? Even the definition of composite number says a number which is having more than two factors is called a composite number. Okay. Now next part is one is neither dash nor dash, neither prime and nor composite. We have already discussed this thing, right? One is neither a prime number nor a composite number. Okay. Okay. Next part. The smallest prime number is what? 2. The smallest composite number is 1 is neither prime nor composite, 2 is prime number, 3 is prime number, then 4. 4 is a prime number? No. 4 is what? Composite number. So 4 is the smallest composite number. Last part. The smallest even number is what? Simply 2. Okay. So now we are done with exercise number 3.2.